So our last topic for today is special products of binomials. We just talked a bit about how we have a special technique called foiling to multiply binomials. And so it's worth now talking about some special ones. Let's say I take x plus 4 times x minus 4. We said we first multiply our first terms, so I have x times x squared. Then our outside terms, minus 4 times x minus 4x. Then our inside terms, 4 times x plus 4x. Then our last terms, 4 times minus 4, that's minus 16. But these two in the middle are like terms. And negative 4 plus 4 is 0. So those will go away. And I'll be left with x squared minus 16. I'm going to call this a difference of squares. X squared is a square, and as we know, 16 is 4 squared. So that's a squared too. Whenever you see something that looks like this, where I have the same two terms in the same order in the two binomials, but the sign is switched, when you multiply that, you'll always get a difference of squares. And whenever you see a difference of squares, you know that it can have come from something like this. We'll talk a lot about undoing this process in just a few classes. So it's good to know that our difference of squares is really useful. Let's write it as a formal formula for ourselves. So we have a difference of squares whenever we have x plus a times x minus a. That's just x squared minus a squared. That's exactly what we just saw in our example, and you'll see it happen a lot. Let's say I have something a little bit more tricky looking. Let's say I have 3x plus 2y times 3x minus 2y. This is more tricky looking, but it's exactly the same thing. Here, this 3x, that's the role of the x in our formula. And this 2y is the role of the a. So I know immediately that this product is 3x squared. Oops, that's different. 3x squared minus 2y squared. And we just talked about rules of exponents, so I know what those are. I think about my power of a product, 3x squared. That's 3 squared x squared, 9x squared. And likewise, that's minus 4y squared. So I don't have to go through my whole FOIL process as soon as I recognize that this is the situation for my difference of squares formula. I have two other interesting things that I can think of, which is what happens when I square a binomial. That is, what if I have x plus 2 squared? I know that's just the same as x plus 2 times x plus 2. Now I can use my FOIL method. First term times the first term, that's x times x squared. Outside, x times 2 plus 2x. Inside, x times 2 plus 2x. Last, 2 times 2 plus 4. These are like terms. 2 plus 2 is 4. X squared plus 4x plus 4. I noticed that my outside and my inside terms were the same. And if I think about it, I know that that will always be true when this started out as a square, right? Since these two binomials are the same, certainly my outside and my inside terms are always going to be the same. So I should be able to come up with a formula that makes my life a little bit easier. When I have what I just had there, which is the square of a binomial sum. That is, I just had a binomial with addition as its operation in the middle, and I squared it. I'll think of that as x plus a squared. So in my last example, x was x and a was 2. That's always going to be equal to x squared plus 2ax plus a squared. That's exactly what we just saw, right? We ended up with x squared plus 4x, and 4 is 2 times 2, plus 4, which is 2 squared. But it would also, again, be true if we had different ones, right? Let's say I had something funky. Let's say I have 3x plus b. And I'm squaring it. I know that if I look back at my formula, I have x plus a squared. So here's x, and here's a in my formula. Then I know that my result is going to be x squared. So that's 3x squared plus 2ax plus a squared. Now all I have to do is simplify those terms. Just like before, that's 9x squared plus, I'll just reorder those so I can simplify the numbers part. That's 6bx plus b squared. I can implement my formula and get something easier than I would have been able to with FOIL. Just a little bit easier, but it can still be useful. Now I have essentially the same thing if I had a binomial difference instead, right? Maybe I have x minus 3 squared. That's x minus 3 times x minus 3. My product of my first terms is x times x squared. Outside terms, x times minus 3 minus 3x. My inside terms, x times minus 3 minus 3x. My last terms, minus 3 times minus 3, positive 9. Again, I'm seeing my middle terms being the same, so I know that I can have a more simplified formula. I have x squared minus 6x plus 9. Now let's think about what our formula ought to be in terms of our x and our minus 3. Certainly, that's my x squared. I don't have to worry about that. Since I had a 2 in my previous formula, I'm going to think that negative 6 is probably minus 3 times 2 times x. That seems like a reasonable hypothesis. And then that 9 is just minus 3 squared. So I want a formula that looks something like that. And in fact, that's what I have. We have a square of a binomial difference now. And we have a formula for that when I have x minus a squared. That's equal to x squared minus 2ax plus a squared. And if I look back, yeah, that looks a lot like what I had predicted. Yeah? All right. We implement this formula just the same way that we just did. Just the same way we did with the square of a binomial sum, right? You determine what your x and your a are. You square it and work out all your terms, and you're good. And it is an easier way of getting where you're going. All of these formulas will become even more useful to us when we do fun with factoring, which comes very soon. For now, you should now be able to do all of the first 6 assignments in Hawks. That is all of the assignments due on the first 2 days.